Today we are going to talk about density, and we discussed density, or actually practiced a little bit about density on Friday when we were in the lab, so that's where I'm going to pick up our discussion about density today. So in the lab you collected mass and volume data as it related to pieces of plastic. So I'm going to focus on a piece of plastic that we labeled as T2. It was transparent. It was a piece of plastic that was transparent number 2. And so the very, very first thing you had to do is you had to find the volume of the piece of plastic, and we did that by collecting length, width, and height data. So the formula for volume here would be length times width times height. So I'm going to substitute in 6.8 centimeters times 3.4 centimeters times 2.4 centimeters, which will give me a volume of 55.5 centimeters cubed. So I'm going to put that in this box, 55.5 centimeters cubed. So the next thing that I have to do is I have to find density, and I do that by using the density formula, which is density is equal to mass over volume. And so I'm going to use the volume that I just calculated and the mass that was found in the lab to calculate the density of that particular piece of plastic. So density would be equal to, in this case, 67.0 grams divided by 55.5 centimeters cubed. So when I go to calculate that, I get a density that's equal to 1.21 grams per centimeter cubed. So that's what you had to do for homework over the weekend, and many of you finished it in class on Friday. But that brings me up to talking more specifically about the density formula. So we're going to talk about it here. Density is equal to mass over volume. So density, D is equal to density. M is equal to mass. And V is equal to volume. Now, a couple of things to keep in mind is that the units for mass could be grams, could be kilograms, or could be milligrams. The units for volume could be centimeters cubed, meters cubed, maybe even millimeters cubed, but also milliliters and the liter. And then for density, our units could be, and I'm only going to do two of them, all of the options, because these are the two that you're going to see most often, would be grams per centimeter cubed or grams per milliliter. But I would like you to know that there are more possibilities than that. For example, you could have kilograms per meters cubed, but we're not going to really deal with that a lot in this particular class. So, the other thing that is kind of nice to think about is that you may remember this from last unit, and this is that triangle of fun that we dealt with. So I'm going to substitute in my variables here. So I have density, and I have mass, and I have volume. And this will allow me to easily identify what my formula is and what math I have to do when I'm practicing. So let's walk through one. In this case, I'm asked to calculate the density of a brick that has a mass of 2,500 grams and a volume of 980 cubic centimeters. So this problem is asking me to solve for density when I know the mass, which is 2,500 grams, and I know the volume is 980 centimeters cubed. So what I'm going to do is I'm going to go up to my triangle up here, and I'm going to highlight what I'm trying to solve for. So that tells me that I'm going to be solving for density, and when I solve for density, I'm going to divide. Oops, that's not what I wanted. I'm going to divide mass by volume. So my formula, density is equal to mass over volume. So I'm going to go ahead and substitute now, because that was my formula. So now I'm going to substitute density is equal to 2,500 grams divided by 980 centimeters cubed. And when I plug that into my calculator, 2,500 divided by 980, I get a density value of 2.55 grams per centimeter cubed. Okay, so that's how we solve for density when we know mass and volume. The next problem is asking us to find the mass when we know the volume of a sample of methanol and we know the density. So this time I know the density is 0.719 grams per milliliter. I am solving for the mass because that's what the problem is asking for, and I know the volume is 40 milliliters. So what I'm going to do is I'm going to go ahead and note that I'm solving for mass. So I'm going to cover up mass with my highlighter, and then I'm going to go back and say, well, that they're on the same level, so that means that they're going to be multiplied. So now I know that my formula is going to be mass is equal to density times volume. So now I'm going to go ahead and substitute my values in. My density is going to be 0.719 grams per milliliter times the volume, which in this case is 40 milliliters. So I'm going to go ahead and solve. Take 0.719 times 40, and I'm going to get 28.8. And in this case, my answer is going to be in grams. So here's my formula that when I work with density problems and I'm solving for just mass. For practice problem number 3, I'm asked to find the volume of a ream of paper that has a mass of 2,300 grams and a density of 0.8 grams per cubic centimeter. So 0.8 grams per centimeters cubed when I know the mass is 2,300 grams and I'm looking for the volume. So I'm going to go and grab my highlighter and note that I'm solving for volume, which tells me that my formula is going to be mass divided by volume. So when I set my formula up, I'm going to have volume is equal to mass divided by density. And so now I can go ahead and substitute in the values that I know, because I am solving for volume. So I'm going to take my mass, which is 2,300 grams, and I'm going to take the density, which is 0.8 grams per centimeters cubed. So when I plug that into my calculator, I get a volume of 2,875 centimeters cubed. So this would be my formula for when I solve for volume. So now we need to have a little bit of a discussion about some conceptual things that about density. So the issue is that all objects have mass and they have volume. Different objects of the same substance can have different masses and different volumes. And hopefully that might make sense. So if I have a piece of iron that is really, really tiny and another piece of iron that is incredibly large, they would have different masses and different volumes, even though they're the same substance, which is iron. But substances can have density. And so what's important to understand about that is different objects of the same substance will have the same density. So below here I have an example in which case I have a small block of cement and a large block of cement. My small block of cement has a mass of 300 grams and a volume of 100 cubic centimeters. So when I set that problem up to solve for density, I would take 300 divided by 100 and get 3 grams per cubic centimeter. I'm going to take my large block of cement, which in this case has a mass of 4,500 grams and a volume of 1,500 cubic centimeters, and I take 4,500 divided by 1,500, and I get a density of 3 grams per cubic centimeter. So it's the same type of cement, and I know it's the same type of cement based on the density. And that's important to understand, is that every object has its own density, or more likely, every substance has its own density. And it doesn't matter if I have a tiny amount of that substance or I have a large amount of that substance, the density will always be the same. Another thing to consider is that when you have differences in density, how that actually happens. So substances that are more dense have either more stuff, which is more mass, in the same amount of volume. So what that would actually look like is that here I have two boxes where the volume is the same, close as the same as I can get it, and in one box I'm going to have maybe 4 particles of that substance. In the other box, I'm going to pack with that substance something like this, or pack with particles of that substance, and when I look at the number of particles per volume ratio, in this case, this one is going to be more dense. So more mass in the same amount of space. Another option that can happen is if I have the same amount of stuff, mass, but in less volume, less space, volume. So what that might look like is if I say I've got 1, 2, 3, 4 particles in one box or object, and I take those same 4 particles and I put them in a smaller box or object, the smaller one is going to be considered more dense. Okay? And then another thing to consider is that substances that are less dense have either less stuff or mass in the same amount of space, volume. And what that might look like would be, here I have 2 boxes that are the same volume, and I'm going to take and put maybe 4 particles in one box and maybe just 2 particles in the other box. And when I do that, the volume of the 2 particles is less dense. And then another scenario would be the same amount of stuff, which is, again, mass, in a larger space, which is volume. So in this case, I'm going to take, let's see, 1, 2, maybe 3, 4 particles and spread them out in my much, much, much larger box. And that's going to give me an instance where the larger box with the same amount of particles is going to be less dense. So the homework for the evening is to do worksheet number 3. Worksheet 3, which is a worksheet on density. It is a 2-sider, so make sure you have that ready to go at the beginning of the hour tomorrow. Good luck.